All right. Good evening, everybody. I want to mention I also am a VWS member. I signed up a few months ago, and I was taking advantage of Don's Monday night nets, and I said, you know what? I need to be part of that group, so I joined up. So uh, we've been. I partnered with a friend of mine, Ted N0THA, earlier this summer. And thankfully, I did because it really helps to do this with more than one person, especially if you have failures on your balloons. You can at least commiserate. But no, it's been a big help to have him as a cohort in this. And I have Eric's name up there, KG0HO. He's a good friend of mine from work. He did all the videoing, which you can see a video of our preparation and launch on YouTube. If just type in N0LX-14, that was our last balloon, and he put up a video on it. So, who am I? I don't know because it won't change screens. Here it is. Uh, I've been a pretty avid QRPer for the last 20, 25 years now. I'm licensed for 1500 watts, they tell me, but I really like to see what I can do with 5 watts or less. And my two favorite ways to play ham radio is pedestrian mobile, like you see on the left, and marine mobile on the right. That picture, and it is, by the way, in Colorado, it's marine mobile, not maritime mobile, because I'm not in saltwater. So freshwater is marine mobile. That picture there on the right is me setting or claiming a world's record for the highest ham radio operating from a boat at 13,800 feet. And that was about 20 years ago. And QST did a little blurb about me, one of those little paragraphs, and then all of a sudden, and I'm not sure how they found out, but Radcom in Great Britain heard about me and they decided to put me on the cover. So it wasn't quite the Rolling Stone cover of the Rolling Stones, but Radcom is pretty good too. Uh, I I made a practice in the early turn of this century. I made a practice of going out in the boat and bringing in the new year with ham radio. So of course that's December 31st, and in Colorado it's very cold. Well, I wanted to do it in my boat, and at 5 o'clock local time, which was 0000 Greenwich time, I would bring in the new year with ham radio. That was quite an adventure, of course. One time I was out and it actually was cold enough, it was starting to freeze and form a thin crust on the ice, on the water, and I had to use the oars to crack open through that thin layer of ice just to get back to shore, but that's another story. So, what is a pico-balloon? Uh, I think Don described it so well, I could probably just go home, except I'm already home. But I can show you what it is not, and that is the latex balloons that they use for, like, it sounds like you guys have done the high altitude balloons also with the latex. As you know, they go up to a certain height, 90 or 110,000 feet, and they blow up and come down with a parachute. Well, pico balloons are what they call super pressure balloons. Um, Basically means they're made out of a plastic film, and they will rise only until they're completely full, and that determines their float level. So, I tell people about pico balloons, and the main thing they want to know is why? What's the purpose? Is there some, social reason, some experimental reason why, this would be worth it? Well, why learn to play piano if you're not going to be at a concert hall? Why bounce your signal off the moon, EME? Well, it's because, it's something to enjoy, personal satisfaction. One of the goals that I have with these balloons, twice it's come very close to floating over Nepal, and one of the last trips it made over, it got within 40 miles of Mount Everest. And so my goal is to be able to say it actually flew directly over, the tallest mountain. Besides that, why do pico balloons? I'm happily married with children, grandchildren, and great grandchildren. But if I was single, I know for a fact this would be a great pickup line. Hey, I've got a balloon at 44,000 feet. You know. But anyway, so what does it take to make one of these balloons? Don mentioned already the balloons and some of the materials he already has. Starts with the balloon. We're using the Yokohama party balloons from Japan. You also need the now you guys can use hydrogen or helium. My personal preference is absolutely hydrogen for a multitude of reasons. Raspberry Pi and the Pico boards, Don will show you that, I guess, during the meeting. We're using 36 gauge magnet wire for the dipole antenna, which hangs down about 34 feet below the balloon. To support the uh, the tracker itself, we don't want to depend on 36 gauge single strand wire, so we use 6 pound fishing line. And the most important item of all is the
Okay.
hamburger meat tray. In order to use the balloon, you have to first pre-stretch it, and they're 32-inch diameter as they come from the factory, but we pre-stretch it to and that's about 100-inch circumference. We pre-stretch it to about 102 inches, gives us just a little bit more volume of air that it will displace once it gets up to altitude. Um, Newsflash today on the Pico forum on groups.io, somebody has a balloon, the same Pico balloons, the same jetpack trackers. He has a balloon that yesterday completed 1 year flying around the Earth multiple times. He did note that he pre-stretched it to 116 inches, which is, I mean, that's crazy because, normally they would blow up at that distance. But anyway, he got it to stretch to 116 inches without blowing it up. The image on the right is a manometer, if you've ever heard of that. It just measures the air pressure inside. You can either use a 120-inch cloth tape measure, or you can use a manometer, or both. And the manometer will measure the PSI inside, and you want to hit about zero point 0.4 to zero point 0.5 PSI. Here's the image of the top of the trackers as I've decided to build them. If you go to the Trackito website, if you guys do that, you'll see a very different layout. I will warn you though, if you try to lay it out the way that Doug, the guy who created all this, the edges of these very, very thin solar panels are exposed, and I think it would be really easy to break them. The solar panels will power about 3 to 4 volts, and the whole thing is only solar powered. And so as soon as the sun comes up to about 15 to 20 degrees above the horizon, it will turn on and start transmitting. As soon as it gets again to around 20 degrees or so on the other side on the sunset, it turns off. Here's the bottom view of our hamburger meat tray. By the way, the size of that is 7 inches by 2.5 inches. And you can see we're trying to reduce weight as much as possible, so we've actually cut holes in that very light foam tray to save every bit of weight we can. Here's what the Pico boards look like when they're new on the left. But there's somebody put out a report that they've been able to trim the boards down right to that little can, that little, I think it's a clock chip. And so the next picture is me trimming it down. I'm saving over 8/10 of a gram, which sounds like nothing, and it is, but it will cause your balloon to fly a little bit higher. And that X-ray looking picture is just that. Somebody X-rayed the board to see where their traces are, and they determined they could chop it off pretty well and save some weight. This is what the GPS telemetry will look like. They'll transmit two-minute transmissions. So the first transmission gives the normal whisper, which is your call sign, your 4-digit grid square, and your power. which in our case is 13 dB or 20 milliwatts. The second transmission, you see it looks like a real funky call sign, Q71. So obviously it's not a real call sign. What that is the Q and the 1 designates part of what designates the frequency and the channel that you're transmitting on. The rest of it is telemetry that encodes the altitude, the GPS altitude, and the speed, and the temperature, and the solar panel voltage, all in that second transmission. Once you've got the whole thing put together, you're ready to prep and fill the balloon and launch it. Here's we're at Ted's nice shop that he's got. It's a way oversized garage. He calls it an outbuilding. He's controlling the helium tank down below the table, and then I'm in charge of taking the balloon as we think it's getting close. We put it on that scale down below, and we weigh it. And we use what they call a subtractive method of figuring out how much lifting gas we've put in there. That weight is a 50-gram weight, and we're looking for something much lighter than that to equate to the payload, and an additional amount of gas called free lift. So we're using between 5 and 7 grams of additional lift to make it actually go in the air as opposed to just staying neutral buoyant. Here's launch day. And again, that's not Ted's house, that's his big outbuilding. And the ideal would be to be able to launch your balloons on a nice grassy surface, whether in your yard or in a football, high school football field somewhere, but nice and grass, because you're going to be laying out a 34-foot length of 36 gauge wire antenna, and you don't want it to snag on anything. What Ted has there is some kind of a wild grass, and it's just like little miniature cactus, and it'll snag at anything. So we've got a big 24-foot tarp that we use to launch all of our balloons off of. And you can see how little the balloon appears to be filled. Well, that's all you need. And then by the time it gets up to 45,000 feet, it'll be a very large round balloon. I decided to, because I'm left-brained enough, I'm trying to be an artist, but left-brain artist is kind of an oxymoron. But I decided to graph our ascent rates. This is the x-axis here is the every 10-minute transmission of Whisper. The y-axis, of course, is the altitude, or the number of feet per 10 minutes that it's climbing. Now that the balloon has lifted off, it will take almost inevitably, it'll take between 3.5 and 4 hours for you to reach full altitude. So for that reason alone, I really recommend launching, mid-morning perhaps, and that'll give you a few hours of at altitude, and you can watch and make sure it's maintaining your altitude, because we've had all kinds of issues with our first few balloons, where they'll go up and reach altitude and come right back down again the same day. So you get your balloon, you get your tracker, and you let it go, and there it goes up into the stratosphere. And you're getting signals from your WSJTX, and you think, oh, this is great. But the question is, what could possibly go wrong? Well, just so happens I have a lot of experience with what can go wrong, so I'm the person to ask about that for sure. This is a plot of my first 3 balloons, number 11, 12, and 13. And those are all within a day. None of those made it over the daylight. They would ascend, and I don't know how well you can see the screen, but all 3 of them reached over 40,000 feet before they decided to plateau and start sinking as fast as they went up. The most likely thing is we were still learning how to properly, make a good seal on the balloon once you have it filled with the hydrogen. And it may have gone up and reached so much pressure that it was able to start leaking out, or it broke the seal of the cap down tape that we used, or who knows, but 3 failures in a row. But if you can see that, the plateau on the top gets longer and longer. First it was 10 minutes, then an hour, and then 2 whole hours that we maintained altitude before it started coming down. What I'm going to recommend you guys, anybody who's interested in doing this, is watch all the videos on YouTube that you can find on Pico balloons. And you will glean a little bit of information from every one of those videos, almost every one of those videos. You'll catch something that you didn't hear, in my talk or from another video or whatever. One of the things that can happen, and it happened to my friend Ted's balloon. He tested it on the ground, of course, and it was transmitting just fine. A solar eclipse, and the solar panels couldn't charge the tracker. Well, that entire rest of its balloon's life, whether it was that day or if it's still floating around the world, no transmissions from Whisper. Turns out that he bought a different brand of enamel magnet wire than I did. And the one that's recommended on the Trachedo website, I think it's Winchester brand or Remington brand. It has a low temperature melting point or, protection point. That's the one you want because what he happened to randomly buy off of Amazon must have been a much higher temperature one. And while he thought he was getting all the enamel off, he didn't. And when he soldered it to the board, locally he was getting a signal, but as soon as it got, less than a half a mile away, we lost all transmission with it, and that was it. So that can happen. Eventually, the lifting gas can leak through the membrane, but as I mentioned before, somebody has actually been flying for 365 days as of yesterday and still going strong at about 45,000 feet. Another thing that can happen is, and this is happening to a few guys where, these balloons are not guided. We don't have the ability to, like Don mentioned, file a flight plan or determine, where the winds are going. Some people end up at or very near the North Pole in the wintertime, and there's just virtually no light to power these things. So until that thing actually drifts with some kind of an eddy current or something down to lower latitudes, you won't they won't hear it for days or weeks. And then all of a sudden you'll get that one transmission, it actually did survive. Another thing that can happen is, these things are flying at 42 to 45,000 feet, and that is above most of the summer storms. Heavy emphasis, capital letters on the word most, because sometimes the cumulonimbus clouds can reach 45 and even 50 or more thousand feet. And all your balloon has to do is not even be destroyed by turbulence. All it has to do is fly through a cloud gently. It'll pick up enough ice crystals or enough moisture that's enough to sink it, and that can bring it down. An example of that, this was my fourth balloon. This is my fourth balloon. And day one, you can see we launched from near Denver, north of Denver. And all the blue circles are 10-minute whisper transmissions. And then the green lines connecting those circles that you see down there by Texas are straight lines. And that's because that's during the night. There's no transmission. And so the algorithm for the tracker page just draws a straight line from the last of the previous day to the first transmission of the next day when it fires up again. So you can tell where one whole day is. Well, just so happens that had the winds been blowing a little bit more towards the east overnight, that Texas stretch of circles there would have been way up around Dallas or even further. And you think, well, no big deal, except for one thing. My balloon was floating at 43,000 feet, plus or minus just a few feet. So 43,000 feet. And when I checked that morning to see what the cloud tops were on windy.com, the cloud tops right near Dallas were at 43,000 feet. So had it gone just a few degrees further east overnight, I could have flown right through that, and that would have been the end of the balloon. So that's cloud tops, especially in the summertime, are a definite potential hazard, which is why personally I like to do everything I can to make the balloon fly at, personally, a minimum of 43,000 feet, but I like 44 and 45,000 feet makes me more comfortable. And there's ways, it's either stretching the balloon larger or reducing the weight of your payload. Those two ratios can make your balloon float higher or lower. Uh, I will say too that my previous lap, I'm about to finish lap 6 on my current balloon. It's off the coast of Baja right now. But the previous lap, it was in the same place, off the coast of Baja, California. And I came and looked at it first thing in the morning, the first transmission, instead of being at 43, 44,000 feet, it was at 30,000 feet. I thought, oh no, it's coming down, because they don't vary that much. If your balloon is at 30,000 feet, that doesn't mean that it's just sinking a little bit to wave high. That means it's done for the trip. Um, and through that entire day, then it kept descending slowly. It finally got to about 26,000 feet. And then of course it stopped transmitting. I said, well, that's it. I'll check it tomorrow morning just to make sure. But the next morning, there it is, flying at 42,000 feet over East Texas. And so when I saw that it was going down, the first thing that I do, and this is the fun part for me, is playing Sherlock Holmes and analyzing with all the whatever data I have access to. And so I went to windy.com. I got the wind speeds. I got the cloud tops. I got the satellite image and everything of that area where my balloon was. And sure enough, going from southwest to northeast, my balloon was skirting this thin veil-looking cloud. It was going right along the northern edge of this cloud, heading for Baja. And but when I went to the cloud top, it didn't show anything. It showed no clouds. I thought, wait a minute, what is going on? Of course, the satellite view did show a nice band of lacy clouds. Well, it turns out that it was a bank of cirrus clouds and probably cirrostratus clouds, so a layer of very thin, icy clouds. At 44,000 feet, it flew through that cloud and gained enough weight with the ice crystals that it sank. But again, for some reason, either it must have evaporated because now it's going to be nighttime and you'd think it would just come down. But anyhow, somehow it dried off. And the next day it was back up near where it belonged over Texas. Uh, Another thing that can happen, and if you guys fly a balloon and if you fly it over Israel or over Russia-Ukraine area, I guarantee you're going to have GPS either jamming or spoofing. And what they're doing is they're sending up powerful signals that appear to be GPS to thwart enemy missiles and fighters and everything. And it will present your balloon, your GPS chip with false information. Here's an example. The first one I experienced. It had overnight, it was over the Black Sea and it just crossed over Crimea. And I looked at it and I said again, oh no, it says 1,000 meters or 3,000 feet. So I said, well, that's it. Made it that far, made it to war-torn zone, and that's it for the day. A few transmissions later, it popped right back up to about 42,000 feet. I thought, what in the world? So that was my first experience of GPS spoofing. Here's a really good example of a guy. His name's, I don't remember his name, KC5UMA. His balloon was over Russia and Ukraine area for, let's just say, a few days. You can tell by the dates down there. And he got spoofed one, two, three, four, about 8 or 9 times. Not only did it give false reporting of his altitude, but also his location. So his location, according to the map, he was all over the place. And of course, the balloon can't do that. So it was all just false information that your balloon, if you're flying in that area, you will see that. The other thing that you'll see is, and apparently, according to the Pico forum that I belong to, no one else had ever seen this before. If you look at the very bottom, the two times that are at the very bottom is 450 Zulu. Well, this balloon, this previous balloon of mine was transmitting the first transmission on the tens. So 420, 430, 440, 450. And you see up above that at 548, uh, uh, WhisperNet is reporting at 548. I go, wait a minute, that's the wrong time. So somehow their GPS spoofing actually told my GPS chip that it was a different time by 2 minutes. I don't know how they do that. So anyhow, that is just some of what can go wrong with a balloon. So the big question you guys might have, and I'll try to answer it first, is this legal? You know, does the government, does the FAA mind that we're flying these balloons up in the 40, 45,000 foot range? And without reading the whole thing, yes, as long as it's under 4 pounds, they don't even want to know about it. This was in their words on their website. We don't even want you to tell us about it if it's under 4 pounds. And as long as your string holding it up has a breaking strength of less than 50 pounds. Well, we're using 6 pound test line, so I think we're good there too. So yes, it absolutely is legal to do this. So N0LX number 15, where is it now? Well, first I'm going to tell you a couple stories. Just a few days ago, I was looking at it and it recorded, I hit a speed of 220 miles per hour. And that's real, that's genuine speed. And that was over Japan. Again, another thing to note if you're going to fly, for some reason, for my last two balloons, the real high jet streams seem to be just off the coast of either over Japan or just off the coast of Japan. And I hit 220 miles an hour, which to me is still amazing that these little toy balloons with these thin little hamburger meat trays and fragile solar panels can survive all this. So that's kind of neat. Also interesting is this was in December, I think the 17th of December. The very top row, you'll see that VK4 station heard me from 19,593 kilometers away. So I checked that and it was a big number in miles, but what I did is I went his grid to the balloon's grid and it checked out to 12,230 miles. So, and I said, well, I wonder, that's got to be literally the other side of the world, right? What they call the antipode. Well, I found a website that will help you calculate antipode. And then I also used another website anyway with the grids. So his receiving station was less than a very bottom row there. His receiving station was less than 280 miles from the exact opposite side of the Earth from my balloon. So as far as whisper at 20 milliwatts, unless you can prove that your whisper signal went long path, that's almost as far as you'll ever go with whisper. Is the other side of the world, straight through the Earth, you know? Uh, Here is an image of all of its laps so far since October when we launched. The two things I wanted to point out here is that that upper one, it reached 56 degrees north latitude last month. So we're talking wintertime and 56 degrees north. There was so little sunlight up there that I only had 4.5 hours of transmission. That's how much daylight it had to be able to transmit. The bottom thing there is just last week, it crossed over the equator to fly the entire day in the southern hemisphere. So that's pretty unusual for a northern hemisphere pico balloon to cross over. So that was pretty cool. This is there. NOAA Weather has a website called HySplit, HY, and then split, and it'll allow you to do predictions up to 10 days, but usually the first 5 days is the most accurate. So this is a 5 day prediction from yesterday when I did this, where the balloon was. It's now, like I say, down further than that, down along the coast of Baja. And by Sunday at noon your time, it'll be down where that red ball is, which is due south of where we launched in Colorado Springs. So as you can tell, I mean, one thing is the preparation, the building, that's part of the fun. The launching the balloon, that's part of the fun. But to be able to understand, like Don mentioned about weather patterns and in my case also geography, you get to learn about where your balloon is, and you wonder, what is that place? I don't even recognize the country because the map is usually just an outline unless you really zoom in on it. So one of the first places I go to is lu7aa.org. The reason I go to that is because this is number one where you register your balloon and the channel you're going to be transmitting on, so all the trackers can know where to look for your balloon. And the main reason I use this page is if I look at it and it's morning time here, but it's over Saudi Arabia or something, and I wonder how much longer it's got to go. I see it's made a few transmissions, but I wonder if it's almost done for the day. Well, that last column where I've got those magenta lines, this particular one where I grabbed it, it's the sun angle was 31 degrees. And I'm thinking, well, depending on its latitude, I wonder if that's the end of the day or the beginning or what. And so the bottom two lines where the arrow and another line is, that is the peak for the previous day is 44 degrees. And then it turned off at 16.2 degrees. And so since I'm at 31 here and it's still climbing, I know that I haven't even finished midday yet. So it's an analysis tool for me to get an idea of where it is and how much longer it's going to transmit for the day. Now, again, here's where it was yesterday about this time when I grabbed this slide. If you go to that, if you're on this tracker page for Trakido and you click on that last transmission, you get a dialog box that gives you the current information, altitude, and all that kind of stuff, and speed. But down the third line from the bottom, it takes you to windy.com, where you can get a global view of the wind patterns at the altitude that your balloon is. Now, windy only goes to 39,000 and then 45,000 is the next jump. And there's usually a difference between those two, but it'll select the closest one to where your balloon is. Altitude-wise, but that little flag there with the white circle, that's where the balloon was at the time. And the cooler the temperature of the color, like towards blue, the calmer it is. And that bright yellow streak off to the right and up on the top, that is 100 plus mile an hour winds for the jet stream. And so again, at the same time, I went to windy.com's cloud top page. And as you can see, the clouds were only at 1,900 feet for that particular time, so no danger of any storms to run into or anything. Again, at the same time, here is the satellite image. And again, it keeps remembering where your balloon is. So that is the location of my balloon and what kind of cloud and weather it's flying over. If you guys have a balloon traveling around the world, and of course, if it's over China or Europe, you're probably not going to, well, on the East Coast, you guys might get to hear it. But so it's in a place where you just can't pick it up on your own antenna. I don't know how many of you probably all know about web-based SDR receivers. You can go to a map of the world and you say, well, let's see, my balloon is supposed to be over about here. And oh, right up over here is a web SDR. And so you bring in the audio from his receiver through a virtual audio cable to your WSJTX, and right on your own computer screen, you'll see your balloon transmitting right down the waterfall. To me, that is really cool to see your balloon 10,000 miles away transmitting from somebody else's receiver. Don, love to open it up for questions for the last 9 minutes.
Hello, my name is Micah. I'm a 17-year-old operator. I was wondering if you, first of all, is there going to be a list of parts available?
Yeah, Don and a couple other guys, we have had some initial talks, and I was able to give some spreadsheets with a list of all the materials and tools that I recommend buying. So yes,
Hey Jake, this is Dean.
yeah.
For everybody in the room, the Makers Group is kind of organizing this build, and yeah, we have the list of parts. Most of the parts are going to be procured already. We'll have it kitted up and ready to go. We're going to do a test build. We're not going to launch a balloon, but we're going to do a test build and make sure we can get all the electronics working and all that sort of thing before we get going. But that should all get going here within the next month or so, and then we'll schedule some time for people to come and these put these kits together, and we'll schedule a launch day and kind of all go out together and have a balloon launch, and we'll take care of procuring the gas and all that kind of stuff, so nobody needs to worry about that. So
And
yeah,
my second question was, where if you decide to use hydrogen as a lifting gas, where do you get that?
Well, same place you get the helium. I do not recommend the party store uh, helium because it's only 80% helium. There is a company that sells from Germany that sells a little bit stronger helium, close to 99%. I recommend the hydrogen for several reasons, but you have to go to a gas supply company. Um, in our area, we have Air Gas. I think they might be nationwide, but they're a little finicky about selling to a non-business. So my friend Ted found a place up by him. It was what I call a mom and pop air gas supply shop for welders, and they were more than happy to sell us, rent us the tank and then sell us the hydrogen.
What's the temperature fluctuation at the different altitudes from the lowest to the highest? And then I assume that impacts the size of the balloon, which will impact its altitude. That's question number one. Question number two is that balloon that was over Texas and you thought you had lost it, was that summertime? And you think proximity to the ground caused it to raise back up? Thank you.
Okay, well, I'll answer the second question first. No, it was just 3 weeks ago or so, about mid-December. So it was definitely not, well, in Texas, I suppose it could be a little warmer down there, and that may have caused the evaporation, bringing it back up. As far as temperature and altitude, I've not seen where the ambient temperature at 44,000 feet changes the altitude of the balloon at all. Of course, it can be 80 degrees when you launch. It'll be the coldest I've seen my balloon report was 44 below zero, but sometimes it'll be closer to right at freezing at the same altitude. So it really depends on the day and the time of day, I suppose.
How large is the balloon when it's at altitude?
Again, it depends on how much it's been stretched, but it's designed to be 32-inch diameter. Mine, having stretched it a couple inches circumference longer than that, it was probably 33 inches or so.
I was just curious. This is K4YMA. Curious about if you found any differences in the two gases that you typically use. Hydrogen is a lot smaller atom molecule.
I believe the same thing when I got into this. Helium is one atom. Hydrogen always comes as a bonded pair molecule. So the molecule is bigger than one atom of helium. So it actually is harder for it to escape out of the balloon. I felt no danger at all with the hydrogen working in Ted's big garage, and we were right by the door and everything. But I felt no danger because you're just squirting just a little bit of gas in there, weighing it, checking it again, and you're using a regulator to turn it off and on. So you're having virtually nothing escape into the air around you. I really recommend the hydrogen because those are the ones that are lasting the longest is the hydrogen-filled balloons.
This is Kevin, WB0POH. I have one quick question. You mentioned that whenever you go over Israel and Russia, you have some kind of a false GPS, that kind of thing. I have another friend of mine who does balloon work, and he supposedly has in his program an automatic shut off because supposedly there's some international regulation you have to turn it off whenever you go over North Korea. Do you have anything like that in your software?
Okay, yeah, it's called geo-fencing. The Trakido does not have it. We've asked Doug, the author of the software, and he sees no interest in putting it in. Uh, the two countries that you're supposed to not transmit over is Yemen and North Korea. Up until last year, it was also Great Britain. No hams in Great Britain were allowed to put a transmitter on a balloon or a kite, period. And therefore, we weren't supposed to transmit either. That's been changed. The odds of you going as far south as Yemen are very narrow. My balloon has gone over North Korea one time. It happened to be at night, so I never did transmit. But I don't think you're going to start an international, World War III by transmitting over North Korea, but you never know.
Well,
Some other models.
yeah, the reason I bring it up is because this friend of mine happened just literally one day after he went over North Korea is when they had that balloon problem. When they had to send out when they shot a balloon down with a. It's like, is it possible? We jokingly suggested that the China response was to his going over in North Korea, but that's another story. Thank you.
GPS chips have built-in limits on the maximum altitude they will measure. One company does make chips for high altitude measurements. Do you know what the ceiling is built into the GPS chips on these devices you just showed us?
I can attest to the first Pico-balloon launch I saw was with the Denver Radio Club, and they decided to use a latex balloon, much to my dismay. I was all excited to see my first Pico-balloon launch because I knew what was going to happen. It was going to go up, it was going to pop. So we tracked it, of course, and it got to 70,000 feet and stopped recording. All the next transmissions were always 70,000, 70,000. So in his software, at least, that's the highest that he will allow it to record. I don't know about the chip itself. Don, I've got a final word if I could. As I say here, this is not the end. It's just the beginning of the journey. Meaning that, if you decide to get into this, there's a whole lot to be learned along the way. And with my talks to a few of you guys over the last few weeks, I really hope to eliminate some of the trial and error. And my goal was to just get you guys to be able to have more success quicker.
Jake, thank
Yep.
you very, very, very much. Jake is going to be our technical consultant, our technical guru as we pursue our build. He's got a wealth of experience, and we're thrilled to have his steady hand and experience. On the board, on the table here before you go, this is the front and back of a solar cell. These solar cells were meant for a satellite launch. They were excess to the satellite. They've been sent to us for Vienna Wireless's use. This is what we're going to use. You don't have to buy them. They've been given to the club. So that's our solar cells. The solar cells power a Raspberry Nano Pico Mini itsy bitsy thingy here. This generates the clock pulses that in turn at the frequency that the whisper needs. And then that goes into this guy. This is called a Trakido Jetpack. We've already ordered these. And these guys are what you hook up the very fine thin wire antenna to. So this is the broadcasting side of it, and you'll see a GPS chip. This is the foam board that you get from your hamburger or your steak or your pork chops. Same stuff. You use this to hold your solar cells. And here's the ultrafine wire that you use for your 20-meter dipole. Half of it goes up, the other half of it hangs down, and you've got a very efficient radiator. So take a gander at these. This is what we'll be using. And then the balloon is, it looks like a tostada. It's not. This is a very finely made, high precision balloon. It is resistant to hydrogen or helium a bit. It stretches to about a meter. And those things go around the Earth if they're handled gently.
Don has some really good connections, it turns out. Got somebody in the government got him a copy of an image taken by a Chinese spy satellite, picture of my balloon floating up in the stratosphere. And so for the first time in public, here is the picture that the Chinese satellite caught of my balloon.